Today we will be constructing linear functions from graphs, tables, and situations. Okay, let's take a look at this first one here. We're going to be taking a look at graphs first. The height of a falling rock is shown on the graph. Find and interpret the rate of change and initial value. Then write the equation of the function in the form y equals mx plus b. That's slope-intercept form. First thing we're going to do is we're going to find our slope. We want to remember here rate of change is slope, and initial value is going to be your y-intercept. Okay, and remember slope is m in our equation and y-intercept is b in our equation. Okay, so my slope here is determined by my change in y. So my change in y from 78 down to 54 is going to be negative 24 because this is a negative slope. Okay, and from 2 to 6 is increasing, so that is a positive 4. So my slope is going to be negative 24 over 4, which simplifies to negative 6. So my equation is y equals negative 6x plus, and it looks like my y-intercept is right here at 90. I'm going to double check that using these points to make sure that this is correct because it's not 100% clear on a graph. So let's use this point here, 10 and 30. So I'm going to use 10 as my x, so negative 6 times 10 plus 90 equals y, which should be 30. Okay, so negative 6 times 10 is negative 60 plus 90 equals 30. Negative 60 plus 90. So opposite signs means we subtract. 90 minus 60 is 30. 90 has the larger absolute value, so it's positive 30 equals 30. This is true, which makes this equation accurate. So my equation for the function is y equals negative 6x plus 90. Make sure you pay attention to that slope being negative here. Okay, let's take a look at another one. The number of trees, bud plants in the riparian zone is shown in the graph. Find the and interpret the rate of change and initial value. Then write the equation of the function in the form y equals mx plus b. Okay, so again, rate of change is my slope, so I'm going to do that first. My rise is my change in my y value, so 13 to 16, we go up 3, so it's positive 3, and then my change in my x value is 2 to 3, so that's 1. So my slope is 3, y equals 3x plus b. All right, and my y-intercept is right here, but it's not on a particular line, so I'm not 100% sure what that is. So what I'm going to do instead here is I'm going to use the x and y value in these points to plug in and solve for b. So y is 13 equals 3, x is 2, plus b, which we don't know. Okay, 3 times 2 is 6, plus b equals 13. Then I subtract 6 from both sides. 7 equals b. Okay, so that would make the equation for my function y equals 3x plus 7. And I am going to substitute one other point in just to make sure I did it right. And we should get 19 equals 3 times 4 plus 7. 3 times 4 is 12 plus 7 is 19. 12 plus 7 is 19. So this is true. So this is the equation for my function. Okay, and again, it is a positive slope, so it's positive here. Here's another one for you to try if you would like, and a couple more if you would like to try those. Let's take a look at number 7 here. Okay, these are tables. Okay, we're going to do the same thing. We're going to find the rate of change and the initial value. So this one says the table shows the amount of flour remaining after baking loaves of banana bread. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and initial value. Then write the equation of the function. Okay, so my rate of change, 16 down to 12, this is negative 4 because we are decreasing, so it's going to be a negative. And this side here, it is increasing by 2 all the way throughout. And negative 4 over 2 simplifies to negative 2. So I have y equals negative 2x plus b. And they do not tell me exactly what my y-intercept is. There's a couple ways that we could do this is we could kind of go backwards, right? If we move up, we're actually adding 4 each time. So we could see, okay, well, if we go down to here, I would go up 4 here this way, and that would get me 20. That's one way to determine it. The other way is to use the x and y value of my points. So I'm going to do that. 16 equals negative 2 times my x value, which is 2, plus b. Negative 2 times 2 is negative 4 plus b equals 16. Add 4 to both sides, and we get 20 is in fact b. Okay, so that means your equation for this function is y equals negative 2x plus 20. And again, x is the loaves of banana bread, and y would be the total flour remaining. Okay, which means each of these points means after 2 loaves of banana bread, there are 16 cups remaining. After you've baked 4 loaves of banana bread, there are 12 cups of flour remaining, etc. Okay, let's take a look at one more here. Okay, the table shows the temperature of an oven as it preheats. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and initial value. Again, rate of change is slope, initial value, y-intercept. Let's take a look at our slope first. So from 155 to 235, we're going up 80, so this is positive. And up 2 on this side, 80 again here, 2, 80, and 2. Now this simplifies. My slope is going to be 80 over 2, which is 40. So I have y equals 40x plus b. Okay, and again, I'm going to substitute in with what they give me. 155 equals 40 times 2 plus b. And I get 80 plus b equals 155. And if I subtract 80 from both sides, I get 75 equals b. So the equation for my function would be y equals 40x plus 75. Okay, and again, I can check that with another point and see that that is correct. Here is another one for you to try on your own, and a couple more if you would like some others. Now we are going to take a look at some situations and writing equations from a situation. Angelica reads 15 pages of a book each day. In 10 days, she reads 200 pages. Assume the relationship is linear. Find and interpret the rate of change and initial value. Again, slope and y-intercept. Then write the equation of the function in the form y equals mx plus b, where x represents the number of days and y represents the total number of pages read. Okay, so they tell us 15 pages each day. This is a unit rate, okay, which is the rate of change. Okay, so they give that to us already. So y equals 15 pages per day because x is the number of days plus b. Then they give us in 10 days, she reads 200 pages. This is like an ordered pair on our graph. Okay, so x would be 10 and pages, which is y, would be 200. Okay, so you would use these points for your x and your y values. So 200 equals 15 times 10 plus b. We would get 150 plus b equals 200. Subtract 150 from both sides, and b equals 50. So 50 equals b. So your equation for your function would be y equals 15x plus 50. Okay, let's do another one together here. Maria collects baseball cards. She collects 20 cards each week. After 9 weeks, Maria has 250 cards. Assume the relationship is linear. So same process here. It says 20 cards each week, so they give us our slope or our rate of change. Y equals 20x plus b. Again, x is the number of weeks, so 9 is my x value, and 250 cards is my y value. And we are going to solve for b. 180 plus b equals 250. Subtract 180 from both sides, and I get b is 70. So your equation is y equals 20x plus 70. Okay, let's do one more together. A large block of ice is melting and losing 5 grams of mass every minute. Losing 5 grams of mass every minute. After 11 minutes, the ice has lost 70 grams. Assume the relationship is linear. Find and interpret the rate of change and initial value, then write the equation in slope-intercept form. Okay, x is the number of minutes, y is the total mass lost. Okay, so your slope is, or your rate of change is losing 5 grams. So this is going to be a negative slope. Okay, y equals negative 5x plus b. They give us the x value of 11, so negative 5 times 11 plus b equals 70 grams, which is the amount lost. That's going to be your total. Okay, so negative 5 times 11, negative 55 plus b equals 70. Add 55 to both sides. 125 equals b. So your equation for your function is y equals negative 5x plus 125. And you can try this one on your own as well as those two if you would like.